Vanakkam one and all. We will discuss problem number 16 of exercise 5.1. Here they are asking us to discuss the continuity of the function where the function has been defined like this. So at first we will know the domain of the function. For the entire real line we have 0, and on right hand side it goes up to infinity, and on left hand side it goes up to minus infinity, and I'll mark some integers over the real line. Now we will see when the value of x is less than or equal to minus 1. So less than or equal to minus 1. In these values the function is minus 2, which is a constant function. And when the values of x are greater than 1 and less than or equal to 1, in this case the function is 2x. The function has been defined as 2x. If the values of x are greater than 1, in such case the function is 2. Okay, so the function has been defined on entire real line. So the domain of the function, the domain of f of x is R, real line. Now we will consider the continuity of the function at x less than minus 1. So we will discuss the continuity at different cases. I am taking the first case where the value of x is less than minus 1. Or we can take, let k be a real number lesser than number where k is less than minus 1. So when the k is less than minus 1, the functional value will be minus 2, because the function has been defined like this. For all x less than minus 1, functional value will be minus 2. So this is the functional value at k. Now we will calculate limit of the function. Limit x tends to k of f of x. Again here the function is minus 2, which is independent of x. So we will get minus 2 only. So here this limit of the function is equal to the functional value, which says the function is continuous for all f of x is continuous for all x less than minus 1. Okay, now we will consider another case. In another case, we will take the value of k as minus 1. Let k is equal to minus 1. So when we have minus 1, the functional value, here they have defined functional value as function as minus 2. Since it's a constant function, f of minus 1 will be minus 2. Now we will calculate the limit of the function in left hand neighborhood. When we have this minus 1 in the left hand neighborhood, the function has been defined as minus 2. Okay, so we will know the left hand limit. So limit x tends to 2, x tends to minus 1, or x tends to minus 1 from, that is x tends to minus 1 from left hand neighborhood. So in the left hand neighborhood the function has been defined as minus 2. So it is going to be minus 2. Now we will find out the limit of the function in right hand neighborhood. In the right hand neighborhood the function has been defined as 2x. So 2x. When we substitute x as minus 1, we will get minus 2. So here left hand limit equal to right hand limit, and this limit value is equal to the functional value at minus 1. So we can say the function is continuous at minus 1. Okay. continuous. At x equal to minus 1, the function is continuous. Now we will discuss another case. We will discuss this interval case. Here we will take the values of x in the interval. So I will mark let x belongs to the interval open minus 1, then open plus 1. Open plus 1. So now in this interval the function has been defined as 2x. Let k be okay. So 2x. So we will calculate limit of the function. We'll take let k be a real number which is from the interval minus 1 to plus 1. So f of k will be 2k, and we will calculate limit x tends to k, 2x will be 2k. So here the limit of the function, limit equal to the functional value 2k, which says the function is continuous in the open interval minus 1 to 1. Now we will discuss the continuity of the function at 1. So at 1 the functional value will be, what about the function? At 1 the function has been defined as 2x. Okay, at the point 1 the function has been defined as 2x. Okay, we will get the functional value as 2 by replacing x as 1, and in the left hand neighborhood of 1 we have the function 2x, and in the right hand neighborhood of 1 we have the function as 2, which is a constant function. So now we will take at 1 the functional value will be 2 into 1, which is 2, and we will calculate left hand limit x tends to 1 from left hand neighborhood. There the function has been defined as 2x. After substituting 1 we will get 2. Now we will calculate a right hand limit x tends to 1 from right hand neighborhood. So where the in right hand neighborhood the function has been defined as 2x. So we will take 2. So it doesn't depend on value of it doesn't depend on x, so we'll get 2. So here left hand limit equal to right hand limit, and which is equal to the functional value. So we can say the function is continuous at 1. F function is continuous at x equal to 1. And now we will discuss the final case when the values of x are a real number greater than 1, where the function has been defined as 2. Okay. Now we will see the final case where the value of x is greater than 1. So here the function has been defined as 2. Okay. So now it's a constant function. So for any real number in the interval 1 to infinity, we have the function as 2, which is a constant function. So which is a continuous one. Yes, so the function is continuous on entire real line. The function is continuous on real line, so there is no point of discontinuity. Now we will discuss problem number 17. Here they are asking for the relationship between a and b for in the function f of x, where they have defined the function like this, and the relation between a and b if the function is continuous at x equal to 3. So to say a function is continuous at x equal to 3, we have to satisfy this equation. Limit x tends to 3 from left hand neighborhood equals to limit of the function f of x as x tends to 3 from right hand neighborhood equals to the functional value at 3. In this case, when left hand limit and right hand limit equal to the functional value, we can say the function is continuous. Here they are asking us to assume the function is continuous at x equal to 3. And if the function is continuous at x equal to 3, what about the relationship between a and b? Okay, they are asking for the relationship between a and b when the function is continuous at x equal to 3. Now we will calculate the functional value. So when the value of x is on entire real line goes up to minus infinity, plus infinity, in center 0, 1, 2, 3, and whenever the values of x is less than or equal to 3, the function will be ax plus b, and when the value of x is greater than 3, the function will take bx plus 3 expression. Now we will calculate the functional value at x equal to 3. At x equal to 3, the functional value is 3a plus b. Now we will calculate the limit. So limit x tends to 3 from left hand neighborhood, ax plus b we will get. Okay, now after substituting, we will get, after substituting x as 3 over the expression, we will get 3a plus b, and we'll calculate the left hand limit approaching 3 from right hand neighborhood. The function is bx plus 3. Now replace x as 3, so we'll get 3b plus 3. Now we are considering the function is continuous at x equal to 3. So left hand limit will be equal to right hand limit. So 3a plus b equal to 3b plus 3, and which is equal to the functional value at 3, which is again 3a plus b. Now consider these two. We need to know the relation between a and b. So I am considering the first two expressions. So 3a plus b minus 3b equal to 3. So we will get now 3a is equal to minus 2, 3a minus 2b equal to 3. So 3a will be 2b plus 3. So this is the relationship between a and b. If we want, we can rewrite this as a is equal to 2 by 3, 2/3 of b plus 1. So this is the relationship between a and b when the function is continuous at x equal to 3.